Today we're going to start graphing, and we graph a lot, and we may not be graphing in the way you think we're going to be graphing, so please follow along so you know exactly what to do. We're going to start off by doing what we've been doing the last couple days with naming the parent function. So this is an absolute value, which means that I have f of x is equal to the absolute value of x. And I'm going to draw my little picture right here. Okay. And then I'm going to look at my transformations. So I have 1, 2, 3 going on here. So that negative means that I always have a reflection. This negative happens after the absolute value, so it affects the y value. So it means it's a reflection in the x-axis. Then the 1 and the 7 are both translations. The -1 means I go to the right 1. And the +7 means I go up 7. Okay, so one of the things I need to be aware of when I'm going to graph are what my anchor points are. So if you don't remember what the anchor points are, you need to go back and look at that organizer for the parent functions. And my absolute value has 3. Okay, so 3 anchor points there. And those are what I use to actually graph. So I'm going to start with this one. So just if you know what the parent function is, you should easily be able to put those points on there and then know that that has to be -1, 1. Those are things you just have to know. So I'm at -1, 1, and I'm going to put my pencil down. And then I'm going to reflect in the x-axis, which puts me right here. And then I'm going to move to the right 1, which puts me right there, and then I go up 7. 1, 2, 3, 4, 5, 6, 7. And that's my new point. That was this point, it's now this point. Then I go to 0, 0. I reflect in the x-axis, which means I go nowhere. Go to the right 1 and up 1, 2, 3, 4, 5, 6, 7. And I'm right here. Then I go here, which is at 1, 1. And then I reflect in the x-axis, so I'm down here. Then I move to the right 1 and up 1, 2, 3, 4, 5, 6, 7. Here's my other point. And then I can draw my line in. Sorry. Can't tell where my pen's going. There we go. And draw this. And I am cheating with a little line function, but I'm not even doing well with that. I'm not in Cami anymore because of some issues. You can't see my cursor when I'm talking, so that's why I'm not doing that. But this is Active Inspire, which y'all do have on your tablets, I believe, and so it's another option to, writing digitally. But that is what your graph should look like. So when I'm looking for these things, I'm looking for everything I wrote up here, and I'm looking for, at the very least, these 3 points plotted, but I really don't think you need any more than that. So then we figure out our domain. Okay, so our domain, and we're going to do this all in interval notation. My x values go from -infinity to infinity. My range is my y values, so I start up here at 1, 2, 3, 4, 5, 6. So this is at a +7, but I always go left to right, bottom to top. So I'm starting at -infinity for my y values and going to a +7. I include the 7, but I never include my infinities. So my x-intercepts, that might be something that I can pull straight off my graph. However, if your line isn't perfect, and mine didn't even actually cross the x-axis, so then I would need to actually solve that. So to find the x-intercept, y is 0, so I do 0 equals negative absolute value of x minus 1 plus 7. So then I'll subtract 7 from both sides. -7 equals negative absolute value of x minus 1. I'll divide through by a -1. So I get 7 equals absolute value of x minus 1. And then that means that x minus 1 could equal 7, or x minus 1 could equal -7. So I get x equals 8 and x equals -6. It asks for x-intercepts, so that means my answers are in ordered pairs. So I would have 0, -6, and 0, 8. Then my y-intercept is when x is 0. So I would need to find f of 0. So that's equal to negative absolute value of 0 minus 1 plus 7. So it's going to be the absolute value of negative 1, which is 1. We make that negative, add to 7, and we get 6. So I'm here at 0, 6. Your critical points are your extrema and points of inflection. So I don't have a point of inflection, but I do have an absolute maximum. So I have an absolute maximum, absolute maximum at 1, 7. It's increasing from negative infinity to 1, because remember these are always intervals of the domain, and then I'm decreasing from 1 to infinity. My end behavior as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches negative infinity. Okay, so just kind of putting all those pieces together. Let's look at the next one. So this parent function here, this is a quadratic. And f of x equals x squared. So I get this for my picture. Right? My transformations, I only have 1, and that I'm multiplying by the 1/4, x lies, so this is a horizontal stretch by 4. Okay, so my anchor points here were 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay, so I'm going to start out at negative 2, 4, 1, 2, 3, 4. And then I have a horizontal stretch by 4. So my x value right now is 2. I multiply that by 4 and it becomes 8. So I need my x value to actually be 8. So that's 2, 4, 6, 8. And I'm right here. Okay, so then I have, this is negative 1, 1. Horizontal stretch by 4. 1 times 4 is 4. So I go to 2, 3, 4. Then I have 0, 0. Multiplied by 4 is 0, 0. 1, 1. My x value gets multiplied by 4. So x value becomes 4. And then I'm at 2, 4. Multiply that x value of 2 by 4 and it becomes 8. So it's at 2, 4, 6, 8. And so that horizontal stretch is making it okay, it shouldn't look as shaky, but you know, we're doing the best we can with this because I'm writing on my tablet. It's better when I write on my board. Just make the points a little bit bigger and we're fine. So when I'm looking for this one, I'm looking for everything I've written here, including this little picture, and 5 points graphed and your function drawn. So then our domain, it's all real numbers, but that is negative infinity to infinity. Our range goes from 0 to infinity, and 0 is included. X-intercepts, I only cross the x-axis once at 0, 0. There's no need to actually do any work for that if it's one of your anchor points that you actually ended up with. And then my y-intercept is also 0, 0. Critical points, well, I have an absolute minimum at 0, 0. I'm increasing from 0 to infinity and decreasing from negative infinity to 0. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. Okay, so there's a quadratic. All right, now let's try a square root. Oh, sorry, can't scroll that way. All right, so this is a square root function. And That's f of x equals the square root of x. Transformations, I have 1, 2, 3 of them. So this 3, when I multiply by, and it says after the square root, so that means this is a vertical stretch by 3. That negative means that it's a reflection. So it's a reflection, and it happens inside the square root, so it affects x, which means it's a reflection in the y-axis. And then that 2 means that I go to the right 2. Okay, and you always do your translations last. Your left, right, up, and down, those are the last things that you do, or your graph is not going to come out correct. So that's why I'm telling you, the more consistent you are, the better, always going from left to right. And then the square root function looks like this. So for your square root function, you had 3 anchor points, 0, 0, 1, 1, 4, 2. How are you supposed to know that? Well, if you know that you have 3 of them on there, 0, 0, you substitute in 1, you get 1. You substitute in 4, you get 2. So that's where you're going there. Okay, now we are not making a t-chart to get our new function though. We're using these anchor points. So I'm going to put my pencil at 0, 0. Then I have a vertical stretch by 3. So my y value gets multiplied by 3, which is still 0. I reflect in the y-axis, which means I go nowhere. And then I move to the right, 1, 2. Then I put my pencil at 1, 1. Right there. Sorry. 1, 1. And then I have a vertical stretch by 3, so my y value gets multiplied by 3, so I end up here. And then I reflect in the y-axis, so I end up over here. And then I move to the right 2, so I go 1, 2, and this is my new point. Then I go to 4, 2, so 2, 4, 2. And then I'm going to have a vertical stretch by 3, so my y value is 2. I multiply by 3, that becomes 6, so that's 2, 4, 6. And then I reflect in the y-axis, so I'll go over here, 4 over here. And then I move to the right 2, so it's 1, 2, and I'm right here. Okay, so those are my 3 points. Then when I draw this in, it looks something like that. I'm so shaky. Okay. So then my domain, my x values, I'm going from negative infinity to 2. I'm including the 2, never include infinities. My range, I start at 0 and I go to infinity. Never include the infinities. I am including my 0. Then my x-intercepts, well again, that's an anchor point, so I don't have to go do any work. That x-intercept is at 2, 0. Now my y-intercept, I don't actually have that, and I don't get to guess, so I have to actually do something for that. So I need to find f of 0. So that's going to be equal to 3 times the square root of negative 0 minus 2. So a negative negative 2, which is going to be a square root of 2. So this is 3 square root of 2. And then my y-intercept, 0, 3 square root of 2. Do not even think about touching a calculator for any of this. I will not accept the decimal. That is the answer. So my critical points, I don't have a maximum. I don't have a point of inflection, but I do have an absolute minimum, which is at 2, 0. Increasing, I'm not increasing anywhere. Okay, my y values the entire time are decreasing, so this is none. And then I'm decreasing from negative infinity to 2. Just realized that I have a mistake on this that hopefully I will remember to fix before I put yours on there, but just in case I don't, as x approaches infinity, okay, x does not approach infinity. X is approaching 2, okay? As x approaches 2, y approaches 0. And then as x approaches negative infinity, f of x approaches infinity. So if I forgot to fix that, fix that. Or if it doesn't make sense on one of the, like the homework problems, then you just need to fix it. All right, let's look at number 4. So this is a cube root. And f of x is equal to the cube root of x. So your graph looks like this. Ooh. I have 1, 2, 3 transformations. That 2 is being multiplied by x, so it is a horizontal. And in this case, x lies, so it's a horizontal compression by 1/2. And then that 1 means that I go to the left 1. And then the 4 means I go up 4. Okay. So my anchor points, I know it's 0, 0, 1, 1, -1, -1. And then 8, 2, 8, 2, and -8, -2. Okay, so there's 5 anchor points here. So I will start with -8, -2. Okay, so I'll put my pencil here. Then I have a horizontal compression by 1/2. So my x value is -8. Multiply that by 1/2. I go to -4. What's that on 8? 1, 2, 3, 4, 5, 6, 7. Oh yeah, 8. So then 1, 2, 3, 4. So here's where I am now because my x value got cut in half. And then I move to the left 1 and I move up 1, 2, 3, 4. Sorry, I got to stop arresting my pencil in there. So then I'm going to go to -1, -1. My horizontal compression of 1/2, so my x value becomes -1/2. Then I move to the left 1, and I go up 1, 2, 3, 4. Ooh. Then I'm at 0, 0. Horizontal compression, well, 0 times 1/2 is 0. Move to the left 1 and up 1, 2, 3, 4. Chutes and ladders. Now, you can use symmetry to find your other points, if that makes sense to you. If not, then we're just going to keep on doing this. I'm at 1, 1, horizontal compression by 1/2, move to the left 1, and up 1, 2, 3, 4. Sorry, now I'm used to doing Cami, and I have to do this differently. All right, and then I'm going to go to 8, 2, and then my horizontal compression by 1/2, so my x value becomes 4. Then I move to the left 1 and up 1, 2, 3, 4. And then here is my graph. All right, so let's look at the domain. The domain, again, is all real numbers, so we're going from -infinity to infinity. My range is going also from -infinity to infinity. Then my x-intercepts, well, eventually I am going to have an x-intercept, so I need to figure out what that is. So that means that my f of x equals 0, so 0 equals cube root of 2 times x plus 1 plus 4. Okay, so I'm going to subtract 4 from both sides. It's going to give me -4 equals the cube root of 2 times x plus 1. I need to get rid of that cube root, so I'm going to cube both sides. So -4 cubed is going to be -64. So that's going to equal 2 times x plus 1. So then I can divide both sides by 2, so I get -32 equals x plus 1. Then I subtract 1 from both sides, and x equals -33. So my x-intercept then is going to be at -33, 0. My y-intercept is right there, but I don't get to, it's right there, but I don't get to gas off my graph. So I need to find f of 0. So f of 0 is equal to the cube root of 2 times 0 plus 1 plus 4. And so 0 plus 1 is 1, plus, or times 2 is 2, so I get the cube root of 2 plus 4. Okay, so that means my y-intercept is 0, and then the cube root of 2 plus 4. My critical points, I do have a point of inflection. This is my point of inflection, and that translated to this. So my point of inflection is at -1, 4. Right? My increasing interval, or my y values, are increasing over the entire domain, so it's -infinity to infinity. And then my decreasing interval is none. For the end behavior, as x approaches infinity, f of x approaches infinity. As x approaches -infinity, f of x approaches -infinity. There you go. That is the end of part 1.